Hello everyone, today we are going to start chapter 3, pair of linear equations in two variables. So consider the two linear equations a1x plus b1y plus c is equals to 0 and a2x plus b2y plus c is equals to 0. Here a1 and a2 are the coefficients of x and b1 and b2 are the coefficients of y. So now these two lines may intersect each other, may be parallel to each other and may coincident lines, that is they lie on each other. So how to identify whether the lines are intersecting, parallel or coincident? If the ratio of the coefficients of x, if the ratio of the coefficients of x is not is equals to the ratio of the coefficients of y, then the two lines are intersecting. That is, if a1 upon a2 is not is equals to b1 upon b2, then the lines are intersecting. If a1 upon a2 is equals to b1 upon b2 but not is equals to c1 upon c2, then the lines are parallel. And if all the three ratios are equal, then the lines are coincident lines. Exercise 3.1, first question, from the pair of linear equations, find their solutions graphically. We have to find their solutions of the given equations. First part, 10 students of class 10 took part in a quiz. If number of girls is 4 more than number of boys, find the number of girls as well as boys. So now let the number of girls be x and number of boys be y. So according to question, it's given that total number of students are 10. That is, number of girls and number of boy is equals to 10. It's also given that number of girls is 4 more than number of boys. So x is equals to 4 plus y. These two are our required equations. To solve this graphically, we need at least two solutions of each equation. Now solving x plus y is equals to 10. We will have, by putting x is equals to 0, we will get y is equals to 10 when x is equals to 0. Y is equals to 10. So at x is equals to 0, y is equals to 10. When y is equals to 0, put y is equals to 0. Then x is equals to 10. Now plotting it on a graph. When x is 0, y is equals to 10. When x is 0, y is equals to 10. So this is our point A. When y is 0, x is equals to 10. When y is 0, x is 10. Similarly, for solving x is equals to 4 plus y, put y is equals to 0 and find the value of x. Then put x is equals to 0 and find the value of y. When y is equals to 0, x is equals to 4. And when x is equals to 0, y is equals to minus 4. That is, taking 4 to the left hand side, we will get y is equals to minus 4. Now plot all these points on a graph. When x is 4, y is equals to 0. That is, when x is 4, y is 0. This one. When x is 0, y is equals to minus 4. When x is 0, y is equals to minus 4. Y minus 4. This one. Now joining these 2 points, we will have equation x is equals to 4 plus y. X is equals to 4 plus y is our second equation. Now the point where these two lines intersect is our required solution. This point is the solution of both these equations. Now x is equals to, at this point, x is 7 and y is 3. 7, 3 is our solution. That is, x is equals to 7 and y is equals to 3. That is, number of girls are 7 and the number of boys are 3. So this is how we find the solution graphically. Just form the equations, then solve the equations and plot it on a graph and find the point of intersection. The point of intersection is our required solution. In part, 5 pencils and 7 pens together cost rupees 50, whereas 7 pencils and 5 pens together cost rupees 46. Find the cost of 1 pencil and 1 pen. So now let the cost of 1 pencil be rupees x and the cost of 1 pen be rupees y. If 1 pencil costs rupees x, then 5 pencils will cost rupees 5x. and 7 pens will cost rupees 7y. So together it will cost rupees 50. So whole amount is equals to 50. Next equation, 7 pencils. So 7x plus 5 pens plus 5y is equals to rupees 46. These two are our required equations. Now to solve it graphically, we need the solution of each these two equations. For 5x plus 7y is equals to 50. To solve this, firstly put x is equals to 0 and find the value of y. Then put y is equals to 0 and find the value of x. When x is 0, 7y is equals to 50 implies y is equals to 50 upon 7, that is 7.14. When y is 0, then x is equals to 10. For the solutions of 7x plus 5y is equals to 46, put x is equals to 0, find the value of y, then put y is equals to 0, find the value of x. Now plot these points on a graph. For this equation, when x is 0, y is equals to 7.14, point A. When y is 0, x is equals to 10. This is our point B. Now joining both these points, this is our required equation. 5x plus 7y is equals to 50. For this equation, when x is 0, y is equals to 9.2. Y is equals to 9.2. When y is 0, x is equals to 6.57. 6.57. Joining these 2 points, this is our equation. 7x plus 5y is equals to 46. Point of intersection is 3, 5. So the cost of pencil is rupees 3 and the cost of a single pen is rupees 5. Number 2, on comparing A1 upon A2, B1 upon B2, C1 upon C2, find whether the lines are parallel or coincident. First part, 5x minus 4y plus 8 is equals to 0. 7x plus 6y minus 9 is equals to 0. Here A1 is equals to 5, B1 is minus 4, C1 is 8, A2 is 7, B2 is 6 and C2 is minus 9. Now A1 upon A2 is equals to 5 upon 7, B1 upon B2 is equals to minus 4 upon 6, that is minus 2 upon 3. After cutting by 2, we will get minus 2 upon 3. Then C1 upon C2 is equals to 8 upon minus 9. Since it's clearly visible that A1 upon A2 is not equal to B1 upon B2. We know that when the A1 upon A2 is not is equals to B1 upon B2, the two lines are intersecting lines. So these two lines are intersecting lines. Intersecting lines. In the second part, A1 upon A2 is equals to 1 by 2. B1 upon B2 is also equal to 1 by 2. Similarly, C1 upon C2 is equals to 1 by 2. So this is a case of coincident lines. In the third one, the ratios of A1 upon A2 is equals to B1 upon B2 but not is equals to C1 upon C2. So this is a case of parallel line. These two lines are parallel and these two lines are coincident. Third question, check whether the lines are consistent or inconsistent. So first of all, what are consistent and inconsistent equations? Consistent equations are those equations which have at least one set of solution. That is, after solving a pair of equations, you will get the value of x and y. But the inconsistent equations are those equations which does not have any solution. That is, after solving a pair of solution, you don't get the value of x and y. The parallel lines are inconsistent and the intersecting and the coincident lines are consistent. If you are asked that whether the equations are consistent or inconsistent, just find they are intersecting, coincident or parallel. The conditions for the intersecting, coincident and the parallel are given. First part is 3x plus 2y is equals to 5. 2x minus 3y is equals to 7. Firstly, find the ratios of their coefficients. a1 upon a2 is equals to 3 upon 2. b1 upon b2 is equals to 2 upon minus 3. And c1 upon c2 is equals to 5 upon 7. Since a1 upon a2 is not is equals to b1 upon b2. So this is a case of intersecting lines. These two lines are intersecting. So when the lines intersect, they have a common point, that is this point is our solution. So the lines are consistent. These two equations are consistent equations. Second part, 2x minus 3y is equals to 8, 4x minus 6y is equals to 9. In this case, a1 upon a2 is equals to 1 by 2, b1 upon b2 is equals to 1 by 2, c1 upon c2 is equals to 8 upon 9. So it's clearly visible that a1 upon a2 is equals to b1 upon b2, that is 1 by 2, but not equal to c1 upon c2. So this is the condition for the parallel lines. These two lines are parallel. Parallel lines don't cut each other at any point. So they doesn't have any solution. That is, these two equations are inconsistent equations. In third equation, a1 is equals to 3 upon 2, a2 is equals to 9. So ratio of the a1 upon a2 is equals to 1.6. b1 is equals to 5 upon 3 and b2 is equals to minus 10. So b1 upon b2 is equals to minus 1 upon 6. Since a1 upon a2 is not is equals to b1 upon b2, a1 upon b2 is equals to plus 1.6 and b1 upon b2 is equals to minus 1.6. So they are not equal to each other. Hence this is a case of intersection, and we know that intersecting lines are consistent. So these two equations are consistent equations. Similarly, in the fourth and fifth part, the ratios of a1 upon a2, b1 upon b2 and c1 upon c2 are equal. In the fifth one also, a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2, that is 2 upon 3. They are coincident lines, that is they lie on each other. And when the lines lie on each other, they cut at every point. So each point is the solution. So lines are coincident, hence the equations are consistent equations. Number 4. Check whether the lines are consistent or not. If they are consistent, find their solution graphically. In the first part, a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. That is equal to 1 upon 2. The lines are coincident lines. This is a condition for the coincident lines. So coincident lines are consistent. So these two equations are consistent equations. Since the equations are consistent, we can find its solution. Now solving graphically for the first equation, x plus y is equals to 5. We will have when x is 0, putting x is equals to 0, y is equals to 5. And when y is 0, x is equals to 5. So plot it on a graph. When x is 0, y is equals to 5. And when y is 0, x is equals to 5. Joining these 2 points, we will have x plus 5, x plus y is equals to 5. Now for the second equation, 2x plus 2y is equals to 10. Put x is equals to 0 and find the value of y. Y is equals to 5. And when y is 0, x is equals to 5. Plot it on a graph. When x is 0, y is equals to 5, this point. And when y is 0, x is 5, this one. So the lines are coincident lines, and the coincident lines have infinite many solutions. Second part, x minus y is equals to 8, 3x minus 3y is equals to 16. Now a1 upon a2 is equals to 1 upon 3, b1 upon b2 is equals to minus 1 upon minus 3, that is 1 upon 3, c1 upon c2 is equals to 8 upon 16, that is 1 upon 2. So a1 upon a2 is equals to b1 upon b2 but not equal to c1 upon c2. This is a case of parallel line. So these two lines are parallel. Since we know that parallel lines doesn't have any solution, so these equations are inconsistent. Third part, 2x plus y minus 6 equals to 0. 4x minus 2y minus 4 equals to 0. Here a1 upon a2 is equals to 1 upon 2 and b1 upon b2 is equals to 1 upon minus 2. c1 upon c2 is equals to minus 6 upon minus 4, that is 3 upon 2. By cutting by 2 we will have 2 3 6, 2 to 4, so 3 upon 2. a1 upon a2 is not equals to b1 upon b2. So this is a case of intersecting lines, that is these two lines are intersecting, hence consistent. If they are consistent, there is a need to find their solutions graphically. So for the first equation, 2x plus y minus 6 is equals to 0. When x equals to 0, y equals to 6, that is when x is equals to 0, y is equals to 6. And when y is equals to 0, then x is equals to 6 upon 2, that is 3. By plotting these points on a graph, we will have when x is 0, y is 6. At x is equals to 0, y is 6. And when y is 0, x is equals to 3. By joining these 2 points, this is our equation 2x plus y minus 6 is equals to 0. Now for 4x minus 2y minus 4 is equals to 0. At x is equals to 0, y is equals to minus 2. That is by putting x is equals to 0, we will have minus 2y is equals to 4 and y is equals to 4 upon minus 2, that is minus 2. So when y is 0, then x is equals to 1. That is x is equals to 4 upon 4 equals to 1. So now plotting these points on a graph, we will have at x is 0, y is minus 2 and at y is 0, x is equals to 1. Now joining these 2 points, the point of intersection is 2, 2. Hence the required solution for these 2 equations are 2, 2. That is x is equals to 2 and y is equals to 2. Fourth part, 2x minus 2y minus 2 equals to 0. 4x minus 4y minus 5 is equals to 0. Now a1 upon a2 is equals to 1 upon 2. b1 upon b2 is equals to 1 upon 2. And c1 upon c2 is equals to 2 upon 5. Since a1 upon a2 is equals to b1 upon b2 but not equals to c1 upon c2. So these lines are parallel. Parallel lines are inconsistent. So these 2 equations doesn't have any solution. Fifth, half the perimeter of a rectangular garden whose length is 4 meter more than its width is 36 meter. Find the dimensions of a garden. Now let the length of the rectangular garden be L and the width of the rectangular garden be B. Since we know that the perimeter of rectangle is 2 into L plus B, so half the perimeter is equals to L plus B. So now according to question, it's given that half the perimeter is 36, so L plus B is equals to 36. It's also given that length is 4 meter more than its width, that is length is 4 meter more than its width. L is equals to 4 plus B. So to find the dimensions of a garden, we need to find the L and B. Let x-axis represents the L and y-axis represents the B. So for L plus B is equals to 36. When L is 0, B is 36. When L is 0, B is 36. And when B is 0, L is equals to 36. Now joining these 2 points, this is our equation. L plus B is equals to 36. Now for L is equals to 4 plus B, we will have L is equals to 0, B is equals to minus 4. This point. And when L is 4, B is 0. Joining these 2 points, we will have the point of intersection at 20, 16, that is x is equals to 20 and y is equals to 16 is the point of intersection. It means L is equals to 20 and B is equals to 16 m. This is the length and width of the required rectangular garden. Next question, given that for 2x plus 3y minus 8 equals to 0, write another equation such that pair so formed is intersecting lines, parallel lines and coincident lines. Now, since we know that for the lines to be intersecting, a1 upon a2 not equals to b1 upon b2. Hence, second line can be 4x plus 5y minus 8 equals to 0. Here, a1 is 2 and a2 is 4. So, a1 upon a2 equals to 1 upon 2. And b1 is 3 and b2 is 5. So, b1 upon b2 equals to 3 upon 5. That is a1 upon a2 not equals to b1 upon b2. Now, for the lines to be parallel, we know that a1 upon a2 equals to b1 upon b2 but not equals to c1 upon c2. So, if a1 is 2, let a2 be 4. So, a1 upon a2 is equals to 1 upon 2. We also need b1 upon b2 equals to 1 upon 2 because a1 upon a2 equals to b1 upon b2 when the lines are parallel. Here b1 is 3. So when b2 is 6, b1 upon b2 equals to 1 upon 2. So b2 is 6. Now c1 upon c2 should not be equal to these two ratios. Here c1 is minus 8. Then let c2 be 9. So now a1 upon a2 is equals to b1 upon b2 but not equals to c1 upon c2. So the equation can be ax plus by plus c. So the equation of second line is 4x plus 6y plus 9. Similarly, for the lines to be coincident, a1 upon a2 is equals to b1 upon b2 and should be equal to c1 upon c2. Here a1 is 2. Let a2 be 6. So a1 upon a2 equals to 1 upon 3. Now b1 upon b2, c1 upon c2 should also be equals to 1 upon 3. For b1 upon b2 to be 1 upon 3, b2 should be 9. So that 3 upon 9 becomes 1 upon 3. And for c1 upon c2 to be 1 upon 3, c2 should be minus 24. So that 8 upon 24 becomes 1 upon 3 and minus should cancel each other. So therefore, second line can be 6x plus 9y minus 24 equals to 0. Question number 7. Draw the graphs of equation x minus y plus 1 equals to 0 and 3x plus 2y minus 12 is equals to 0. Determine the coordinates of the triangle formed by these lines and the x-axis and the shade the triangular region. Firstly, we have to draw the graph for these two equations. For this, find the solution of each equation respectively. For x minus y plus 1 equals to 0. When x is 0, y equals to 1. And when y is 0, x equals to minus 1. Plot it on a graph. At x is 0, y is 1. And when y is 0, x equals to minus 1. Joining these 2 points. This is our equation. X minus y plus 1 equals to 0. Now for 3x plus 2y minus 12 equals to 0. When x is 0, y is 6. And when y is 0, x is 4. So plot it on a graph. At x is 0, y is 6. At y is 0, x is 4. X equals to 4. Joining it, we will have the point of intersection. The two lines intersect each other at 2, 3 and to the x-axis at -1, 0, 4, 0. Thus the coordinates of the triangle formed are 2, 3, -1, 0, 4, 0.